Hi and welcome to this final video where I'm going to talk about the last factor that can really affect the solubility of a sparingly soluble ion or salt, and this is really the formation of a complex ion. Now some of you might be familiar with complex ions from level 2 if you did the 2.2 standard looking at ions. However, for many of you, complex ions will be quite new. So starting off with, what is a complex ion? Well, there's a lot of chemistry behind complex ions, which I really don't want to get into in this video. So all I'm going to do is say that complex ions are charged particles which consist of a central metal ion, which is usually a transition metal, although aluminium and lead can form complex ions as well, surrounded by a number of ions or molecules which are attached using what are known as coordinative or dative bonds. Okay, so the surrounding particles, metal ions or molecules, are known as ligands. You may come across that term in some things. And there are usually between an even number, 2, 4, or 6 ligands. The common ones that you'll come across are typically water, ammonia, hydroxide, and cyanide. That's in this particular standard. Okay, so you do get a list of complex ions, the formulas of these complex ions provided in your resource sheet. And these complex ions are as follows. Now, don't get too hung up on these. I'll show you a little bit more about how they work in a second. The specifications for the assessment state that there could be other ones provided as well, but you'd be given more data about them. It doesn't actually matter which one is used, okay, because they all work exactly the same. You'll notice that when you see them, first off, they're in square brackets and there is a charge on the outside of the square bracket. That charge is the overall charge on the ion. It's a complex ion because it has a charge on it, right? And inside it you've got usually your metal ion and then something else in brackets, cyanide, ammonia, hydroxide, whatever. Some of these things are charged ions and some of them are neutral. So ammonia is neutral, hydroxide and cyanide are charged. Water is also neutral, but there's no standard ones in this particular assessment that have water in them, though you do find them a lot. Okay, so when it comes to complex ion formation, usually the complex ion is being formed from one of the dissolved ions in the equilibrium. So because you're removing that ion out of the equilibrium equation to make a complex ion instead, then that's going to reduce the concentration of that ion in solution, moving the equilibrium to the right or favouring the forward reaction, which is ultimately going to lead to more of the salt dissolving and therefore increasing the solubility of the salt. So that's the general explanation for any question, right? The complex ion is going to remove that ion from the right hand side of the equilibrium, which is going to force more of the salt to dissolve to replace what's been taken away. Now the equations, they look really horrible and scary, but all the data that you need is provided in the formula for the complex ion. Okay, so it's formed from a metal cation and either a series of molecules or anions. And you can always figure it out. So here's an example. Okay, zinc hydroxide, or the zinc hydroxide complex. It's made from zinc 2+ ions and OH- ions. You can see by looking at the formula that there must be 4 OH- ions and that overall charge is going to be 2-. Now, you do have to know your ions. I've said this before and I will say it again. You must learn your ion table if you don't already know it. Okay, all those things that are on the level 1 ion table you must know by heart. But if we've got zinc hydroxide, then we've got zinc 2+ ions and hydroxide ions. There must be 4 of them because there's 4 in that formula. So you just stick them together, and as you can see, the overall charge on the complex ion is 2-. So we've got 2 pluses and 4 minuses, which gives an overall charge of 2 minus. So even if you can't quite remember the charges on one of the ions, you should be able to figure it out. Okay, here's another example. Nickel ammonia complex. It's made from nickel 2 plus ions and ammonia molecules. Ammonia is neutral. So you just go, okay, well, what have I got? I've got 1 nickel, I've got 6 ammonias. Let's bung them together. There's my formula. Next example, silver cyanide, right? Silver plus, cyanide minus, bung them together. There's the formula. Okay, so you will use these when you are discussing what's happening in the formation of your complex ion. As long as you've got the formula of the complex ion, which, like I say, is provided on the resource sheet, then you will be able to work it out. So here's an example from 2016. Explain how the solubility of silver carbonate will change if added to 50 ml of a 1 mole per litre ammonia solution. Support your answer with balanced equations. No calculations are necessary. Okay, so don't feel like you have to calculate anything for it. You just need to figure out what's happening. And so it comes back to what I was just talking about. Okay, so we've got silver carbonate. It's dissolving and it's forming equilibrium with the dissolved ions, silver and carbonate. Okay, there should be an equilibrium arrow in there. I don't know why I've forgotten it. So when the ammonia will react with the silver ions and form the ammonia silver complex. And here's my equation for that. Right, again, just taken straight from what I know. Then the explanation of how that's going to affect the solubility, because that's what the question's actually asking. Okay, that's going to remove the silver ions from the right-hand side of the equilibrium equation, which will have the effect of shifting the equilibrium to the right, favouring the products dissolving more silver carbonate, and therefore increasing its solubility. I hope you found this useful, and I'll see you again soon. Thanks for your time.